Hello again. In this video, we will switch from Google Colab to Amazon SageMaker, and we will try to blend our segmented image to a podium background. So the car looks like standing in a podium. Amazon SageMaker is similar to Google Colab, but while in Colab you can access Google services like files in your Google Drive, in SageMaker you can access AWS services like accessing data in S3 buckets or using other AWS services. So let's take a look in the code. This is how SageMaker looks like. You can open SageMaker, and then you come here in instances, and then you can create a SageMaker a notebook instance, and then inside that instance you can create a notebook. I'll be using for this example PyTorch, so I created a PyTorch instance, and we will end up with in a screen like this. I have already pasted the code here. I also created an S3 buckets where I have some files. I put our downloaded model here, so now we will load the model from an S3 buckets, and I put some test images, and I saved some outputs, and let's see how it works. Let's run this. Let's run everything. Okay, so here I'm importing the modules. This time I'll be using some basic image processing here. This is for accessing S3. So in S3 we get HTTP responses, and then in the body we can read the response as a byte stream, and then you have to wrap it in a bytes.io to treat it like a file. So we can actually read from an open file, a virtual file that is open, and we can see that the model is there, and then we can set it evaluation mode, and it has the same structure as before. So this file here is the one that we saved in our last video. I downloaded to my computer and then uploaded to an S3 bucket. So now we don't have to download it from the internet, and if PyTorch changes the model or it's not available anymore for some reason, our product, our deployment won't rely on internet sources. So it's all bundled together. In the next video, actually, we will put the model inside a Docker container, so we'll not be using S3, but still it's a nice way to show how you can load a model from S3. The same way, I loaded an image from the same bucket. It's a similar image, has the same name, but it's not actually exactly the same image. We read it from a buffer, and here we do the pre-processing. In the last video, this was bundled together with the weights, but now we don't have the downloaded weights, so we don't have the pre-processing. So by looking in the input and the output, this is not actually equals the documentation, but it's actually what it was doing. If we look what was happening in the pre-processing, so we just resize it, convert it to float, and then do some standard image normalization. So the image now we have to convert it to a tensor because it's a NumPy image, and then we pre-process it, and you see that this looks like our batch looked like in the previous video. So the categories here I copied also from the weights, so I just printed it and then copied here because we don't have the categories now. They are not bundled with the model anymore. And then I run the prediction just like the last example, and I get the mask like we did last time. So this we did in the last video too, nothing new, basically the same code. And now we start doing something, we start using OpenCV here. It's very basic image processing here. I try to do this simple and straightforward so these videos get short and clean. But basically what I'm doing here, and I'm finding the image contours, external contours, and then I get the contour with the maximum area, get the area of each contour, and then the index of the contour with max area, and then draw the contour. Why I'm doing this? I'm doing this because I want to rescale the image so that it fits in my background. First, also, if I have some blanks inside the car, I will print then the contour. If you remember in the last video, we had a glitch inside the car because the mask had some very low values in this area here. So now we can draw contours, we can draw a field contour. If I do like this, and then we can generate a field mask. Yeah, so we can generate a field mask like a white mask, and then if there are some glitches, we can fix it. So let's keep this. This is just to show. Let's now we have the contour, and then I load here the background, and you see that the image sizes they are not the same. This is a little bigger, and then we have to rescale this car and move it so that every car that we take the picture, it it will be comprised in this area here. So the x coordinates come from here, a little above 100 to 500, and then we scale the height of the image to keep the aspect ratio. So that's what I'm doing here. I get the boundaries of the contour, and here I have this fixed image coordinates. I'm using here 140 as the start x, and 530 as the end x, and 380 as the y of the bottom, so the height of the. So these three coordinates mark 2 points here, and then I make three I get the three corners of the contour, like the right bottom corner, the left bottom corner, and then the top left corner here. And what I do is I will make an affine transformation in this image so that this image here is moved and rescaled to this area. So here I get this will be the left bottom corner, then the right bottom corner, and then this is the top left. So here I calculate the scale, the difference of the width of this area here to the original image to rescale it and keep the aspect ratio. Then we do an affine transformation, and the original image, this image here, is rescaled and moved to this area here, and the output image has the same size as this image here because I'm using the podium the podium shape here. And then we blend the images. This is similar. I just draw the contour with a field to make a mask, and then I warp the mask so it becomes the same as the image. And we do here I did a foreground computation and then background computation, then add them together. There are OpenCV functions to do this, both for thresholding, for adding, and etc. And here we have the moved image too. So this one doesn't look very good because the orientation of the car is not very well suited for this kind of blending, but you can see that the car was moved here, and the size of the car and the position. So the same code here, I bundle them in 3 functions that are the functions that I will use for deployments in the next video. So I made a function here to do the pre-processing and then return the image in the output, then to get the contour, and then to do the blending. And last, I did another test to just to test that the functions are working and use an example of a car that is better suited for this kind of blending. So I downloaded another image from the S3 bucket. Uh, then here I use the 3 functions: get mask, get the contour, and do the image blending. And here is the output. This is the original image, and then the blended image with the podium in the background and the car in the foreground. That's what I wanted to show to you in this video. Hope you liked it. On the next video, then we will get the image actually not from S3 but from base64 encoded image, like a ASCII string, and we will use Docker and the client, the command line interface for AWS, and then we will uh, use it to deploy it to uploads and create the networking on AWS and create a Lambda function to do this segmentation automatically. So keep tuned for the next video. See you.